Good morning. Today is April 19th, and this is the last week of class. So we made it all the way to the last week of class. I'm going to share my screen. There are a few assignments as usual, and let's get right into it for today. I have to make a couple of quick adjustments here, make visible, and more I need to make visible. Now I'm going to go to student view. Okay, so again, this is the last week of class. Congratulations. It's almost over. Let me just go through a few housekeeping notes, and then I will we'll be ready to wrap this up. So assignments today, article review 8 is due, or tonight. Don't forget to do that. So next, there are article review 9 is due next week at 11:30 p.m. And then also due next week, you have research quiz 4 and globe outdoor assignment 2. Okay, so also for this week, the reading assignment is the political and cultural geography of Russia and neighboring countries. Last week, we focused upon the physical geography and environmental problems in Russia and neighboring countries, which brings us to research quiz 4. Okay, so listen very carefully. Research quiz 4 is only for those of you who are not planning to be teachers. So if you're not planning to be a teacher, you'll do this quiz. It's pretty straightforward. It's just like the other 3 quizzes that you took. You have the quiz here that covers Unit D, which is Russia and neighboring countries. And so it's the same deal. Just be sure that you pay close attention to where the references are from or must be from. Answer the questions here. Well, don't answer these questions. Be sure to scroll down for the map and the population pyramids. And of course, you will complete the answer sheet here. It's just like the other 3 quizzes. If you have any questions, please ask. Do not procrastinate on this assignment. You really should get started early on everything this week, because my plan is to release the final exam on Friday. That's the plan. I'm going to try to do that so that you will have as much time as possible to finish the final exam project. So the final exam will actually be a project. It's not going to be an exam. There will be a project that will take you, well, you'll have a week to complete it, or up to a week, up to the 29th. The 29th of April is the last day of class. That's it. Well, last day of the semester, excuse me. The last day of class is actually, for this class, the last day of class will be Wednesday. The last day of the semester is the 29th. That's it. And then after that, there's of course graduation, and the grades will be due, I think, on May 7th or something like that. So if you can get as much as you can out of the way this week, you will have as much time as possible to work on the final exam project. Okay, so that is the assignment for those of you who are not planning to be teachers. For those of you who are planning to be teachers, you will do the second globe assignment. And so remember, you all are, those of you who are teachers or planning to be teachers, your goal is to become globe certified, which is a 4-step process in this class. You've already completed the first step, which was the first globe exercise. This is the second one. You'll do the last 2 parts during finals week. So I'm going to walk you through this exercise. It's entitled Globe Assignment 2, Outdoor Weather Data Collection. So the whole point of the Globe program is to engage your students or your future students in hands-on scientific inquiry. So this outdoor weather data collection is an example of the kind of assignment your students would do, but we are making an adjustment here because of COVID-19 and we're not meeting in class. Normally we would complete this assignment during class, outside. We would collect all the data and this would be done in maybe a class period, but we can't do that. So we have to do this in an alternative format. And we'll see how it works. I've done this for the last 3 semesters. It's worked out okay. So here's the assignment itself. So it's called the Globe Teacher e-training. And this is the second part, weather data collection outdoor exercise. And so as you can see, you will do some prep work before going outside. So in any scientific activity, process, work, we have to be prepared. And so we have to do some things before we go outside. Be patient, read these instructions carefully. Hopefully, if you have any questions, again, reach out to me. Try to get started on this early. Don't wait till next Monday to start working on this, or else you're probably not going to finish it. Okay, so let's get started here. Okay, so before going outside, you're going to download or get the Globe Observer app. It's just an app. It's a free app. It's called the Globe Observer. You can see it there. Globe Observer. You can click the link there, put it on your mobile device. That's step 1. So you will use the Globe Observer app to do a globe clouds observation. We're actually going to do cloud observations 2 ways. You're going to do one with the naked eye and by hand, so to speak, and then you'll do the second one with the app. The Globe Observer app actually is an app that was developed for citizen scientists who want to participate in Globe. Globe started out being primarily for formal education institutions, public schools, private schools, used by teachers who were licensed. But because the Globe program in the last 25 years has become so popular, a lot of other people outside of formal education institutions and schools wanted to do Globe. Boy Scout troops, Girl Scout troops, Boys and Girls Clubs, various after-school programs, whomever also wanted to collect atmospheric data and other data using Globe. And so Globe created this app. and you will be using it. Okay, so that's step 2. Step 3 is for you to find the nearest weather station to you. And we're going to use an unofficial weather station. And the reason that we're doing that is because we're not able to meet as a class. Normally, we would go outside with liquid filled thermometers. Chances are your students will use liquid filled thermometers that they would hold in their hands, and they would take temperatures and learn how to read the thermometer. But obviously, we're not going to be doing that. But this is a substitute, and it's always good to have a plan B. Anytime you're doing anything. So you'll go to the Weather Underground site, and the Weather Underground site is a site that has weather stations that are owned by just private individuals, not official weather stations. We'll talk about those later. But this is just a site that has locations of weather stations in various areas. So here in the search bar, you should probably go type in your zip code area. And so I'm just going to use 37209. That's Tennessee State University zip code. And let's see what we come up with. So this is the weather station. Now, when you get to this page, you'll probably want to figure out, okay, exactly where is this weather station that's near me? You can go here. And when you hit change, notice you'll get the weather stations that are close to you. And I think that the one that is closest will be at the top. And so I clicked on it. Notice I clicked on it, and now let's try that again. Okay, so here are the weather stations, and now I can see the weather stations on the map. There's Tennessee State University, and really this one, 62, that says 62 degrees Fahrenheit is the closest one. That's Sylvan Park. So notice that that weather station lights up. So I'm going to use the Sylvan Park weather station. Okay. So that's the weather station I'm going to use. That's the one that's closest to me at Tennessee State University, or if I was at Tennessee State. You do the same for your weather station. Then you're going to take, here's a link to the Sylvan Park weather station. Again, this is just some private individual's weather station that he or she voluntarily pasted data to this platform. And there it is. So again, we're going to get data from that weather station. So it says here, if you're using a liquid filled thermometer, practice reading it indoors. We don't have one, so we're doing it this way. Next, the latitude and longitude for where you happen to be taking your observations. So at this point, you should go outside to where you're planning on taking your observations and get the latitude and longitude. You don't necessarily have to be at your house. You can go to a nearby park. I would strongly recommend that you go to a park. It's a lot easier to see the sky, or if there's a school down the street, or shopping mall, or just someplace like that. So there's an app called Where I Am, and you see here's the Where I Am app. It gives you your latitude, longitude, just like that. So you can put that on your mobile device. There's also another app that's called Where Am I At? One of these, I think the Where I Am At is for iPhones, and the other one is for Android. So I don't know if you can see, because you can't really see anything, but it's giving me my latitude and longitude. Or you can go to Google Maps, and let's see, if you go to Google Maps here, and we've done this before, same procedure. So Google Maps, I'm at Tennessee State University, and just get as close as you can to wherever it is on campus you are. Normally we would be here in the normally we would be right here in the old courtyard taking these measurements. So we usually be right here. Just click on the map, drop a pin down, and you will get your latitude and longitude for your location right there. Just simply record that long location. Don't take the degrees, minutes, and seconds. You want the decimal degree location, lat long, just like I just got. And then just simply paste that into your Word document, just like that. And now you have the latitude and longitude for your sample location. Okay, now that's before you go outside. Now, when it's time to go outside, record the date and the time. Make sure you include the time zone in there. Some of you all are not in Nashville, I know. Record the date and your time zone, and then you will get the temperature you'll get the current temperature from your local weather station, which will be in degrees Fahrenheit. So I'm going to go to my local weather station, and it says 62 degrees Fahrenheit. So I'm going to fill that in, 62 degrees Fahrenheit. And so now I'm going to convert that to degrees Celsius, formula there. So I'm going to take, I'm going to convert. So here, so 62 degrees Fahrenheit minus 32 times 5 divided by 9. So that's about 16.6 degrees Celsius. Okay, so now we want to get the precipitation from the local weather station in inches. Pretty easy. Just scroll down the page, and you can notice there's no rain here, no precipitation. This usually provides some graphics here. Let me see if, okay, I should be able to scroll down. Yeah, click on it and you get some graphs, and then notice here's the precipitation graph. Nothing. So here's the time, April 19th, 24 hours. So with that, however much precipitation has occurred whenever you take your reading, that's what it is. So no rain, no precipitation at all, at least for me. And then of course that's 0. Okay, so next you will make a globe clouds observation using the cloud chart. The cloud chart and other materials are provided for you here. So what essentially you will be doing is completing the globe clouds 1-day data sheet. I have, in addition to this video, but I have much more in-depth instructions for how to complete a cloud observation here. But I'm going to walk you through it in simple terms here. So here is your clouds observation sheet. Now, what you could do, and what I did, is, of course, when you're outside, if you can't print this out, let's say you don't have a printer, just take a screenshot of it and then save it as a JPEG and then put it on your phone just like that. Put it on your mobile device just like that. If you can't, the glare is horrible. I think you can see it a little bit. If you can't print it, if you don't have a printer available. If you have a printer available, then simply print it out, complete it with the pencil, take another screenshot of it when you complete it, and then you can upload it to your Dropbox when you're done. Okay, so two ways that you can do this. Either put it on your phone and take a separate sheet of paper, and as you go through the steps, just answer each of one of these questions on a separate sheet of paper. Just be prepared, be organized before you go out there outside so that you don't make any mistakes. Okay, so let's get started. So you'll fill out, put your name here. That's your name. The study site, if you're at a park or maybe the name of your neighborhood, don't put your address here. If you're at Tennessee State University's campus, then put TSU main campus. The year, month, day for date, and then for now, just put in your local time in hours and minutes. Don't worry about the universal time right now. Okay, step one, what is in your sky? What is the total cloud or contrail cover? Is the sky obscured? Now, if the sky is obscured, then you can't see the sky. Okay, it's either heavy rain, heavy snow, haze, volcanic ash. Don't think anybody's going to be experiencing that. But in most cases, the sky isn't going to be obscured. So just look in the sky, look at all the clouds, and just estimate what percentage of the sky is covered by clouds. Just what percentage, and of the whole sky, that you can see. What percentage? So on the included with the your materials is the globe cloud chart. And so here you can also take a screenshot of this and save it if you can't print it out. That's what I did. So you can have the globe cloud chart on your mobile device. So I have it on mine, and then you can simply use it to make your observations. And so as you can see, one of the, so here you have cloud cover. So here's an idea of what cloud cover looks like if it's in one of these various ranges of cloud cover percentages. And you just record that on your sheet, and then go on to step 2. Sky color and visibility. Color, is it blue, deep blue, blue, light blue? Again, compare that to what you see here on the sky color portion of your cloud chart and making that estimation. Now, normally what we would do if we were all outside together, we would all look at these colors and come to a consensus. And that's what you should do with your students, have them work together, collaborate, and then come to a consensus. How many of us think it's blue, light blue, and then whatever the group agrees with, that's what's entered. So this allows for students to collaborate, work together, so on and so forth. Next, visibility, same thing here. Is it unusually clear, clear, somewhat hazy? Some of you all might be in Georgia or Alabama, just maybe farther south of Tennessee, or you might be in East Tennessee where there's a lot of pollen in the air right now, a lot. And it might be kind of hazy because of the pollen. But just make your best guess of which one of these it is and then fill that in your answer. So that gets us past step 2. Then go to step 3, high level clouds. So your high level clouds are cirrus clouds and contrails. Contrails are clouds that are made by airplanes. So if you see those up there, you record them. Then the cirrus clouds either comprised of ice droplets. They're very high. It's very cold. You're over 3 miles above the Earth's surface. And so those clouds can be made of ice crystals sometimes, or they can be water droplets. Clouds are not water vapor, by the way. Water vapor is invisible to the naked eye. So if you can see water, it's not water vapor. These are either liquid droplets or ice crystals. Okay, so next we have mid-level clouds. And again, just look in the sky, come as close as you can to estimating what you're seeing, whether they're stratus clouds, or cumulus clouds, or low clouds such as stratocumulus. Just look in the sky and just make your best estimate. This is something that you'll get better at as you move along in doing globe. But for right now, we're just getting started. Make your best guess at what kind of clouds are in the sky. Are they high level? And just check them off. If you don't see any high level clouds, and you might not, just click no high level clouds. If you do see high level clouds, then next you have to go to, again, look at the percent of the sky that's covered by just those high level clouds. And then what is the opacity? And that is whether you can see through the clouds or not. And so the opacity is also here. You have, it can be transparent, which means you can see straight through the clouds, or translucent, which means you can see light shining through the clouds, or they're opaque, which means you can't see through the clouds and you can't see light coming through them. They're just very dark clouds. So those are the 3 types of cloud opacity, and then you can just record those for each level. So you do the same thing for each type of cloud height and form. So that takes you, that steps 3, 4, and 5, different kinds of clouds. And then your surface conditions, is it snow, is there snow and ice, standing water, muddy, is it dry ground, or the leaves on the trees? And we're speaking in terms of leaves on trees. This is speaking specifically to deciduous trees, mostly. Now, some of you might be in a part of the country where you have broadleaf evergreens. You might be in Louisiana, Florida, somewhere where it's green all the time. But whatever it is, just record yes or no. Are you out? Is it raining? Is it snowing? Yes or no. The temperature, you should go back and get the temperature that's at the local weather station or your nearby weather station at the time that you are outside. And so you can either get that from your mobile device. You can just get the temperature right before you go outside to take the observation. That should be fine. You can also, if you want, get the barometric pressure and relative humidity. And so you'll probably have to convert the pressure into millibars from inches. You can find some online application to do that pretty easily. And then, of course, there's your humidity, so on and so forth. You can record those if you want. Definitely get the temperature, the pressure, and humidity. not that important, but I really would like for you to get the temperature. So however you can fill this chart out. There are several ways I told you can do it. If you have questions, let me know. I know not everybody has a printer, and so just let me know about that. Okay, so now you've done the globe clouds observation using the globe cloud chart. And so that's all of these. And after you finish the sheet, just in addition to uploading it to the Dropbox, just also email the sheet to me. I just want to take a look at it to this email address, just so I can take a look at it. Now, while you're out there, again, you're doing all this at once. This is not 2 different days. Okay, we want to get this. We want to have the same or similar cloud cover. Again, ideally, we would have one person doing the naked eye or hands-on observation, and then another person would use the app. That's how we would ideally do that. Or you would have maybe one student doing it by hand and another student using the app or what have you, or however you can work that out. Okay. Because in all likelihood, you might find yourself in a classroom situation where only one student, maybe a few students, have mobile devices that can manage the apps, or maybe you'll be fortunate enough to get a small grant and get some iPads so you can make some observations. But you might not, you can't assume that you're going to be in a classroom where every child is going to have a smartphone, especially if you're talking about little children. Of course, they're not going to have a phone. So you have to find some other way of working around that. Okay, maybe you just use your phone. Or like I said, maybe you could get an iPad. In any case, next you're going to use the Globe Observer app to make the cloud observation. It will essentially walk you through the process. It's a relatively user-friendly app. The Globe Observer app, again, was created for just novice citizen scientists. So you should be able to work through this pretty easily. If you have any problems, just let me know. Let me know right away. You'll just walk through the steps. Be patient. Really what you should do is do kind of a practice, not the day that you're going to make your observations, maybe the day before you're going to make your observations. Just do a practice session with the Globe Observer app, just so you can kind of see how it works, or if there's some kind of a glitch, or if it tells you to do something and you don't understand what it's asking you to do, then you can talk to me. But practice makes perfect. After you finish your observation with the app, a few days later, you will get a NASA cloud observation satellite match. So NASA has satellites that are orbiting the Earth, that are taking cloud observations. So this particular satellite, this is what you'll get in your email a couple of days or maybe a day after you make your observation. So notice the satellite records the exact same data that you record: high clouds, percent cloud cover, and so on and so forth. Now, in this case, the student observed high clouds, middle clouds, and low clouds. And there weren't a whole lot, so there were a few. Less than 10% of the sky was covered by clouds, but the satellite didn't see any clouds. So this exercise illustrates the point that we still need human beings to make observations in science, and especially in natural science and outdoors. That these satellites, as wonderful as they are, these remote sensing instruments, as wonderful as they are, cannot see everything. And so we still need to have humans on the ground making observations to somewhat validate what appears to be seen by the satellites. But in some cases, a satellite will see things that we miss. So it's kind of a trade-off. So so when you go, you'll make your observation, you'll answer all these same questions that were on the data sheet. Then you'll be asked to take some pictures of wherever it is you made your observation. They'll show up here. So after that, the next thing that you're going to do is go to the weather.gov. So now the weather.gov is the official government weather station that is used by meteorologists on the news at night. So when you watch the news at night, the meteorologist gets his or her information from the National Weather Service stations. So 7209. And so the weather station that I'm given is the John C. Toon Airport. And so I'm going to take this link and I'm going to copy and paste it right here. So that link should presumably take me back to the John C. Toon Airport. As a matter of fact, you should probably just make a note of exactly what that site is, just so that you can have a complete piece of work here. Okay, so now you've done all that. Next is the question portion. So the first question asked, how do the weather conditions at your local weather station, temperatures, cloud cover, etc., compare to your local natural weather station forecast? So let's see, let's just kind of work through that. Okay, so here's a National Weather Service station, 63 degrees Fahrenheit. Sylvan Park Station says it's 63.9 degrees Fahrenheit. Very close, very close. Sometimes those can vary. I mean, if you can look at this map here, you'll notice that one weather station has 68 degrees Fahrenheit, one has 64 degrees Fahrenheit. If we look at the wind direction, these little arrows, so here's one near downtown, near Vanderbilt. Wind is coming out of the southeast, blowing towards the north, but then over here, there's one that's not too far away where the wind is going in the opposite direction. So what this shows us is that atmospheric conditions can vary across a relatively small area. And so that's why the more observation points we have with these privately owned weather stations, the more information we can gather about what's happening on the ground. So you'll do that comparison. Are the differences in temperature, or the differences in cloud cover, or the differences in precipitation, humidity, or what have you? Why might these differences be present? Maybe one weather station you might notice is in a more urbanized area and it gets hotter than the other weather stations. So there are lots of, just kind of elaborate on whether you notice the difference between those two, the official weather station and the private weather station. Compare your globe cloud observations, compare your observations to the satellite observations. Were they different? Did you notice? Were there any differences? Please record those. Was there more clouds, higher clouds, so on and so forth. C, did you notice any other interesting weather atmospheric phenomena while you were making your observations? You had to have seen something else that was interesting while you were making your observations. Don't just say, I didn't see anything, Dr. Padgett. I was just out there. Just look. You look around. You want your students to be inquisitive. You want your students to ask questions. And this is what this is about. Maybe they see something that wasn't part of the assignment per se. Let's talk about what that is. And it could be anything. It could be an unusually shaped cloud. It could be that pollen. Maybe they see that haze. Okay, what's that about? Can we talk more about that haze? There might be something else happening. Maybe you're out of the time of day that the moon is rising during the day. I'm sure you've seen that. Anything that's interesting. Maybe there's lightning off in the day. Well, you don't want to be out there when you see lightning. But anyway, what did you learn? Did you find anything interesting? Yes, I'm sure you find something interesting about this exercise. Maybe speak in terms of how you might use this in your classroom with children of a certain age, maybe 10-year-olds, 5-year-olds, whatever. How would you use this as a teacher? Perhaps that's something else you can expound upon. Submit this entire form to the Dropbox in addition to your cloud observation sheet. And your satellite match if you get it. Just return all that to me. So again, those are the assignments for this week. Again, Article Review 8. I'll talk about the political and cultural geography of Russia and neighboring countries, which will be somewhat of a help to those of you completing the quiz this week. And don't forget to do Article Review 9. So thank you very much for your time and attention. I have a noon meeting, so I have to get to that right now. If you have any questions, please contact me anytime.